Okay, so if we were going to do this kind of just as a trial and error approach, we kind of need to look at what happens. So the cost of coffee and tea is £4. Now, a lot of people would go, oh, £2 each, but that's not true because we've got a second piece of information, which is cost of buying a coffee and 3 teas is £7. What's the difference between those two situations? Or what's the difference? So we've got a coffee and we've still got a coffee. Good. So we've got a tea and then we've got 3 teas. And the information is £4, £7. So logically speaking, adding 2 more teas made the cost go up £3. So 2 teas cost £3, which means 1 tea costs £1.50. Okay, and if a coffee and a tea is £4, then obviously a coffee must be £2.50. Okay, so we can kind of do that one in our head, like I said, and maybe we can transfer this to your maths book now. We can also do it, which I saw you doing, Ian, which is writing the simultaneous equations. So what are the simultaneous equations? Well, I'm going to define my variable that a cup of coffee is a C. That's the cost of a cup of coffee. And T is the cost of a cup of tea. You can do X and Y's or A's and B's if you like. I'm just doing coffee and tea. So the cost of 1 cup of coffee plus the cost of 1 cup of tea is equal to £4. The second equation would be 1 cup of coffee plus 3 teas equals 7. So there's your 2 equations. So how did we deal with those? Well, we did equation number 2, subtract equation number 1. So we're looking at it and went, well, we have minusing 2 teas minus £3. So we've got 2 teas equals 3. Therefore, 1 tea equals £1.50. And then I'm going to use T equals £1.50 in equation number 1. So C plus £1.50 equals 4. So therefore C equals £2.50. All right. So the algebraic way is just a formal way of writing down what you were doing in your head anyway. Okay. Yeah. Did you figure out where you went wrong with yours?
Yeah, because sir, you know how there's like different ways to do the simultaneous equations. What I did, which makes no sense now, instead of like leaving it as C plus T equals 4 and C plus 3T equals 7.
Yeah.
I decided to try and get the T's the same, so I times the top one by 3, like to make it 3T, but like I did the wrong thing.
Well, let's just try that. So if we times this one by 3, we would have 3 C's plus 3 T's equals 12. And then we would have the second one is still coffee plus 3 T's equals 7. Is that what you had?
Yeah.
Yeah. So this time, if we do 1 subtract 2, do it that way round. So 3 C's subtract C is 2 C's. This goes. 12 subtract 7 is 5. So 2 C's are 5. 1 C must be £2.50. So, I mean, it's not a bad approach. It was 1 step more than you needed to do, but it could have still worked. Fine. Okay, looking at the next one then. So this is a very common type of one. Okay. The sum of Rosemary's age and Hannah's age is 102 years. The difference between Rosemary's age and Hannah's age is 52 years. Rosemary is older than Hannah. Find the age of each woman by using the simultaneous equations this time.
So if it said by using simultaneous equations in an example, you have to use.
Yeah. So to get the marks, you would have to show evidence that you've done your simultaneous
But if
equation.
you got the final answer without using it.
Yeah.
Get it.
No. Do you want to have a go maybe on your board first? Or... So a trial and error method would be, well, if they add up to 102 years old, we've got Rosemary's age and Hannah's age. We could start with they are both 51. But that's not a difference of 52 years. That's a difference of no years. So what would you do? We know Rosemary's older than Hannah. So we could go... So if we did... just had a guess. So there's got to be a difference of 52 years, 102. So add 10 on, 61, and that would be 41. But that's only a difference of 20. Difference of 40 would be add another 10, so 71 and 31. Yeah?
Because you put it into a ratio.
In what way?
The age is 2 to 1. Or 1.5 to 0.
Do we know that though? We're not told that Rosemary is like double Hannah's age or anything like that. That's if we were told that, then yes, that would be a reasonable way to do it. I mean, I definitely wouldn't be doing this trial and error method myself, but I just thought we can have a look at it. So this would be 40 years. We need 52. So adding 10 on and taking 10 away makes a difference of 20 years.
You'd add 6 minus 6.
Add 6 and minus
Yeah,
6
right.
gets another 12. So 77 and 25. Okay. They definitely add to make 102, and 77 minus 25 does make 52. Okay. So you could do this a trial and error method. However, it does say use simultaneous equations. So I think you've already done this, haven't you? Which is the first equation is to do with the sum is 102. Okay. So you would write R plus H equals 102. And the next piece of information is the difference
Added R minus H
is 52. And yeah, because we know that Rosemary is older, okay, we should do R minus H is equal to 52. Right, so there's your two equations. And what would you do now? Well, your R's are the same, so we could subtract to get rid of the R's. This is bigger than this, so let's do equation 1 subtract 2. So we've got positive H subtract negative H gives you, so H subtract negative H is 2 H's. H plus H. And that equals 50. Because 102 minus 52 is 50. Right. We've got that. Therefore, H must equal 25. Plug it into up here. You get R equals 102. Take away the 25, which is 77.
No.
This was trial and error. Yeah, trial and error work. That's what I'm saying. But it won't get you any marks. Why won't it get you any marks? It says by using that. All right. But I guess you could do trial and error to give yourself an idea of what the answers were, and then try and set up your equations if you like. Right. But it is about setting up your equations. And the thing about it is there's a limited number of ones that they will ever ask you to do. Now, over to you then. So you are working on this worksheet, all right, we have just done question 1 and question 2. You've got question 3, 4, 5, 6, 7, 8, probably up to 7 for you to do yourself in your book. Joke.